All right, welcome to our first lesson for chapter 13. Chapter 13 is all about soil and its uses. So to start with our first lesson, we're going to do an introduction to soil. So learning goal here is that you will be able to describe the geologic processes that go into the formation of soil. And we have a few success criteria. So by the end of this lesson, you should be able to describe the structure of the earth and identify each layer, describe the geologic processes of weathering and erosion, and identify the factors that affect soil formation. And then just a reminder, as you're taking those notes, anything highlighted in yellow is like an important note, and then anything in green is going to be like a key term, like a vocabulary term. So let's look at the study of soil as a science. So soil science is the study of soil as a natural resource on the surface of the earth, including soil formation, classification and mapping, physical, geological, biological, and fertility properties of soils. And these properties in relation to the use and management of soils. There are people that their entire life is dedicated to studying soil, figuring out what it needs, what we need, how to preserve it, and all of that. So soil is on the earth, and so this will make a little bit more sense as we get through the lesson, but first we're going to talk about the structure of the earth. This is something you should have learned before, but just in case. Way at the inside of the earth, we have the inner core. This is a solid core. Then we have this outer core, which is kind of liquidy. And then we have the mantle. So the mantle is going to be liquid, and then right on the outside, we have the crust. And then these outer layers of the mantle. So this is the big part of the mantle. And then the asthenosphere is the plastic part of the mantle. So it's kind of like the texture or it's like melted plastic. Not quite liquid, not quite solid, kind of in the middle. And then the outermost of the mantle is solid. And then on the tippity edge, we got the crust. So this is the crust, and then this thin blue right here is going to be the ocean. So we have oceanic crust, that's under the ocean, and we have continental crust, that is, under the continents. And then the outermost mantle, that's solid, and the crust makes up the lithosphere. So that crust on Earth is broken up into different plates, kind of like puzzle pieces, and these are the tectonic plates. So the crust of the earth is extremely thin, less dense solid, covering over the mantle, kind of like an eggshell over the egg. And then the mantle makes up the majority of the earth and surrounds a small core of iron. The outermost portion of the mantle is solid. That portion is right under the crust. And the crust and solid outer mantle, like I said, are known as the lithosphere. The asthenosphere is a thin layer below the outer mantle capable of plastic flow. And then plate tectonics is the concept that the outer surface of the earth is made up of large plates of crust and outer mantle that are slowly moving over the surface of the liquid outer mantle. Heat from the earth causes the slow movement, and the plates are pulling apart in some areas and colliding in others. This is another thing that you should have gone over in some previous science class, so this hopefully is review, but just in case, we're going over it again. These building processes are counteracted by processes tending to make elevated surfaces lower. So moving on from plate tectonics into those geologic processes that we were going to talk about. So chemical weathering involves the chemical alteration of rock in such a manner that it is more likely to fragment or be dissolved. There's some sort of chemical change happening that makes the rock weaker. Rock fragments exposed to the atmosphere may oxidize or hydrolyze, which makes them weaker. And then the process of actually moving those particles, so loosening and then redistribute them, is called erosion. So a lot of times when we see that a rock has weathered and then eroded away, we just call it erosion. But the actual breaking down is weathering, and then moving those particles is erosion. So this could be physical fragmentation, physical weathering. When water gets into cracks, when water freezes, it expands, and so that breaks the rock apart, or it could just run, the water could just run along the rock and kind of slowly but surely weather and erode it away. Weathering processes are important in reducing the size of particles that can then be dislodged by moving water and air. Mechanical weathering results from physical forces that reduce the size of rock particles without changing the chemical nature of the rock. So it's mechanical, it's just one force acting on the rock, like water or wind. So that could be freezing and thawing cycles. It could be plants and animals. So if we look at soil and land, land is the portion of the world not covered by water. If it's water, and if it's not water, it's land. Soil is usually on land and is a mixture of minerals, organic material, living organisms, air, and water that together support the growth of plant life. If we are talking about soil, soil is technically a living thing, like it has living things in it. So it is a biotic factor in the environment. It is made up of organisms. There are organisms in soil. Soil without organisms, that's dirt. Dirt is dead. Soil is living. So if we look at good agricultural soil, so what we want to grow our food, we would have about 45% mineral, 25% air, 25% water, 5% organic material, and then we'd also have, so that organic material is organisms, roots, and then humus. So when we are forming soil, when the earth is forming soil, there are different factors that contribute to that. And that is time, parent material, climate, biological factors, and topography. So soil formation begins with the fragmentation of parent material, whatever the soil is coming from. So the specific type of rock or sand or whatever that it's coming from. That's the parent material. Parent material consists of ancient layers of rock or more recent deposits from lava flows or glacial activity. And the first organisms to gain a foothold in modified parent material also contribute to soil formation. So when we talked about primary and secondary succession, soil formation is happening in primary succession. So those first organisms, those are going to be our pioneer communities. So lichens form those pioneer communities. And then decomposition of dead lichen further alters the underlying rock, and that's adding that organic material. And then humus is the organic material resulting from the decay of plant and animal remains. It mixes with top layers of mineral particles and supplies needed nutrients to plants. So that's how plants in the wild get their nutrients. They don't have artificial fertilizers being put on. They get it from things dying and decaying. It creates a crumbly soil that allows adequate water absorption and drainage. And burrowing animals such as earthworms bring those nutrients up from deeper soil layers, improving soil fertility. All right, that is the end of this introduction lesson. Please let me know if you have any questions, and I will see you in the next one.